Alright, so let's go over this RF plasma flame generator circuit. Alright, the first thing we want to look at is this step-down transformer. This is a small, I think it's a 1.5 amp, oh I'm sorry, it's a 28 amp. It's a 12 volt, 28 amp, 120 to 12 volt transformer. And that transformer comes over and it is connected to one side of the bottom pin, bottom left, and the bottom right. And it has a small capacitor connected in between the two. And that is connected to the bottom two pins of this GU5B tube transistor. And it's got 4 pins, the two on the bottom. It's the one on the right is a negative, and the one on the top is a positive. And that's where your positive high voltage connects. If you trace it back, it goes through the antenna, down, around through a capacitor, 6,000 volt capacitor, 8 microfarad, and then it goes to the top side of your high voltage transformer, which would be an array of actually 3 microwave transformers in parallel on the primary side, and on the secondary side everything is in series. So your other end comes out and it connects to the negative of your bottom 2 pins where your other transformer connects. And then it also has a diode that goes across the positive and negative, which converts it to half-wave DC. And then there's a cap across the diode. There's a capacitor, actually 2 capacitors connected in series that are across the diode, and that helps to smooth out the loads so that you don't get a pulsed effect. You get constant DC, because you're actually going to pulse it down here on the transistor through the bottom 2 pins. You're going to pulse it at whatever frequency you want, which is why this transformer setup needs to be modulated. So it needs to be modified a tiny bit so that you can modulate that frequency and produce whatever frequency you want, or plug in an audio tone and it'll play that audio tone through the output there at the top in the form of plasma. And this right here, this KPI-8, is a variable capacitor. It's a variable capacitor, which means you can tune it. That way you can tune your antenna to the proper, because what this is this is a RLC circuit. And so that's your C, your capacitance. Your R is this resistor. This is actually a variable resistor, 1.5 kilo ohm, 150 watt. And you can tune your resistor. And so you have a resistor, a capacitor, and an inductor. And that makes a RLC tank circuit, or a resonant circuit. By tuning properly, and the way you tune is by tapping in your positive to a different location. You find where your resonant point is. You either move it up or down. And you tune your capacitor and you tune your resistor. And then once everything is in resonance, then you will get a plasma flame emission out of the top at whatever frequency that you're putting into the system. And that's how the RF plasma flame generator works. Now let me show you what this tube and some of these components actually look like in real life. Here's what the tube looks like. So as you can see, it's got a big heat sink on the top, and then it's got your tube in the middle, and it's got your pins on the bottom. And that's your pin layout. And that's what your tube looks like. It's a power triode tube, Russian made. This is old school Russian military tech. 3.5 kilowatt triode tube. And the cool thing about it is you can run these things in series and in parallel for more power. We could really build a powerful system with some tubes like this. They're $100 a piece, so really not that bad. There's 10 available. Whoops, and there's all the information on it. But it's pretty straightforward. The max output voltage is 5 kV, so we'll have to step our. We'll just go with 4,000 volts with 2 transformers instead of 3 on our power supply, and then because this tube can only handle 5,000 volts, so we better keep it to 4. So that'll be good, because then the schematic doesn't have to change at all, and everything is just as it should be. And so let me show you what some of these capacitors look like. So these are called doorknob capacitors. They're a set value. They're non-tunable. These are some of the components that we're going to be using when you see the symbol for capacitor. This is what it's physically talking about. It actually is about the size of a doorknob. It looks like a doorknob. So this is the high voltage vacuum variable capacitor, also Soviet made. That's a very cool component. A vacuum variable capacitor. And here's a variable resistor that I found. This is a 1.5 kilo ohm, 150 watt, 1200 volt standard shaft linear rheostat is also another name for a variable resistor. But I think the voltage rating on this one is too low, because we're going to be at 4,000. We would need 4 of these in series. They're $100 a piece, but I don't think this is the right product, so I'll keep looking. So really the only thing we have left to cover is this capacitor, this diode, and this capacitor, and the transmitter coil itself. But we'll talk about that later. Anyways, peace.